Hey guys, this is Carrie, and this is going to be the answer key video for homework number 10. So a parabola and its directrix have been graphed above. Which of the following points are the focus? So what you want to be remembering for this question is when you have this set up, you have your focus, you've got your directrix, and then the parabola goes with its vertex exactly in the middle between them. So the vertex of the parabola passes at the midway point, exactly in between the focus and directrix, so that will mean that this part and this part are the exact same measurement, because this is the middle. Okay, so using that idea here, we know that the parabola passes through the middle, so since this is the vertex of the parabola, which is at point 5, 2, we know that that will be exactly halfway in the middle of the directrix and the focus. So it looks like these are 1, 2, 3, 4, 5, 6 units apart. So that means the focus will be 1, 2, 3, 4, 5, 6 units down. And 6 units down from 5, oh wow, that's a typo, 5, -2, should have been the answer there, sorry for the vertex. 6 units down from 5, -2 will be the point for the focus. Let me use a different color. The focus will be 5, -8. Let's see. Why does it face downward this time, the parabola? Well, it faces downward because it always wraps around the focus. What is the equation of the directrix for this parabola? So this one's a little bit more complicated. One thing that you can notice about this problem is that it's not in the format that we usually like. We usually like our parabolas to be in what I call vertex form. So x minus some number squared plus some number, and then sometimes we have a coefficient. We usually call it a there, and oftentimes it's like some sort of fraction, like whatever. So we want it in this format. So the first thing we're going to do is we're going to solve it into this format. So we start off with our equation, -8 y minus 3 is equal to x plus 4 squared. Now rather than distribute the -8, the way I like to do this problem is I like to divide by -8 on both sides. So that will give us y minus 3 is equal to, and in our standard form here, we don't have the parenthesis with x over some number. Instead we've got a fraction here. So what we want to think about is how do we write division by -8 as a fraction? So we can write that as 1 over -8, but instead of dividing by a negative, a positive divided by a negative would make that whole fraction negative. So this 1 over -8 becomes -1 over 8. Now we've got the rest of our parabola like usual. Last step to solve for y is to add 3 on both sides, and that gives us y equals -1 over 8, x plus 4 squared plus 3. So the answer to this problem isn't immediately evident. What we can do is we can draw a rough sketch of it. So the first thing that we want to sketch is the parabola. So we know the vertex of the parabola is going to be coming from these points. So usually a parabola has vertex at the origin. An inside transformation of +4 is going to shift it to the left, opposite what we expect, right? You would think +4 would be to the right, but opposite what we expect, left 4. So we go left 1, 2, 3, 4, which is -4. Outside transformation will shift us up 3. So we go up 1, 2, 3. So 1, 2, 3. Our parabola is going to be downward facing because our a value is negative. Now there's one more thing we need to discern from our a value, which is we have a formula. Usually to find the a value, we know it's 1 over 2 times the total distance between the focus and the directrix. So it must be that the distance between the focus and directrix is equal to, well, 1 over 2 times the distance. It must be that this is 4, so 2 times 4 give us the 8. So it must be that the distance between the focus and directrix is 4. So I wish I had a little more room to write that. Let me write it up here. All right, so the distance between these is 4. and the parabola is in the middle of them, then using the diagram from the last problem, if this distance is 4, it will mean that this distance here is 2, and this distance here is 2. So it must be that our focus is down here, 2 units below, at -4, comma, +1. And it must mean that our directrix is 2 units up at y equals 5. Now how did we know to put the focus on the bottom? Well, because this was downward facing, it had to wrap around the focus. So y equals 5 is the equation of the directrix. That's a pretty tough one. That's about as tough as these focus directrix problems are going to get. Completely factor this expression. All right, so now with 4 terms, it might seem obvious that this is a factoring by grouping problem. But let's see where it gets a little more complicated. So if we try to factor it as it is, we get x squared plus 3xy plus 3x cubed plus y. So from our first 2 terms, when we split it into groups, we factor out an x, and that gives us x plus 3y. From our next 2 terms, what do these share in common? They don't share anything in common, so the most you can factor out is 1, and that leaves you a 3x cubed plus y. And that is not a good factoring by grouping problem because these 2 things are supposed to match. So factoring by grouping appears to fail, but it doesn't actually fail. The reason why factoring by grouping works is before you solve this problem, we have to put it in standard form. So we'll put it with the highest powers of x first. 3x cubed plus x squared plus 3xy plus y. And now when we solve it, we get, let's see, splitting into groups, we get x squared from this first group gives us 3x plus 1, plus y from this next group gives us 3x plus 1 again, and now they match. So factoring by grouping is actually successful. So we get 3x plus 1 times x squared plus y. So an important idea with factoring by grouping is if it doesn't work the first time with 4 terms, make sure your original expression is in standard form. Next up, we've got written in simplest form where c is not equal to d. This is equivalent to. So we want to simplify this fraction. So we're going to look at first to see is there anything that can divide the whole top and the whole bottom. And it's kind of slim pickings. We could try c, but since c doesn't divide d, we can't divide the whole top. We could try d, but since d doesn't divide c, we can't divide the whole top. It looks like we have a 2 here, but none of the other terms have a 2, so we can't reduce the whole top and the whole bottom by 2. So it looks like we're in trouble with this one. What really we're supposed to do here is we're supposed to realize that we can factor the numerator and denominator here to generate some common factors that would cancel out. So this is a sneaky factoring problem, which I guess the theme of this problem set is some sneaky problems. But this factoring problem, it doesn't look like difference of squares maybe at first, but since we have a perfect square here and a perfect square here, this is actually difference of squares. That gives us c minus d times c plus d, just like difference of squares normally does. Now on the bottom here, you might be like, well, this is another funky factoring problem. Instead of having one variable like we usually do, we've got 2 variables. So this is like, I'll call it funky sum and product. And let's see how sum and product works with this. So we'll set up our sum and product puzzle. D times d gives us the d squared. But now we're trying to look for 2 numbers that, well, it's weird. They're not really numbers. We're trying to look for 2 numbers that add to c and multiply to negative 2c squared. So you can write that as an equation maybe if that makes it easier. 2 numbers that add to c and multiply to negative 2c squared. So it looks like they're both going to have c in them, because c times c is c squared, and when we combine c terms, it gives us c. Now, we're looking for 2 things that multiply to negative 2. So maybe 2c times negative 1c. 2 times negative 1 is negative 2. C times c is c squared. And that would mean 2 plus negative 1c here. And 2c plus negative 1c does give us c. So these are actually our sum and product numbers. plus 2c, and minus 1c. And so what we can do now is we can cancel out the like terms, but this is a little problematic. It doesn't look like anything's alike yet. So let's keep going one step further. We've got c minus d times c plus d all over d plus 2c times d minus c. Now, even though we don't have any like terms, we do have two terms that are very similar. This term right here and this term right here. So because these terms are so similar, the only thing that differs in them is this is the wrong signs. And what we saw in the last problem set for homework was that if you want to flip the signs of something, all you have to do is factor out a -1. So looking at our answer choices, it looks like d plus 2c is a good denominator to have, so I don't want to factor out the -1 from here. I want to change the numerator. So let me factor out a -1 from this red circle group right here. So factoring out a -1 would make this -c plus d. It switches the signs. Negative times negative would give us positive. Negative times positive gives us back negative. This is still c plus d. This is all over d plus 2c. This is d minus c. Now we finally have our like terms that cancel. D minus c is the same thing as d minus c here. That gives us -1 times this. So we distribute that, -1c minus 1d all over d plus 2c. And I think now we see which one is our answer choice. It's choice 3. All right, so tough problems. But I guess we've already been reviewing factoring for a while, and I wanted to preview what the two most difficult factoring problems that I've seen on the Regents look like. Now for the next two, these are a little bit more straightforward. These are our polynomial division problems that I think we're feeling really good at. I'm going to skip going over problem 5 because problem 6 has an interesting, I think an interesting result in it. Maybe not. Let's see. I think problem 6 is an interesting result, so I'll go over that one instead. So which of the following is the quotient when f of x is divided by g of x? So we have 4x cubed minus 2x squared minus 6x plus 9 divided by 2x plus 3. We know this is going to equal to our giant purple quotient. Now to solve this, we multiply by 2x plus 3 on both sides to turn it into a multiplication problem. And that gives us 4x cubed minus 2x squared minus 6x plus 9 equals 2x plus 3 times our quotient. Now we figure it out term by term. 2x times our first one has to give us 4x cubed, so this needs to be 2x squared. That gives us 4x cubed. However, that also creates for us 3 times 2x squared, which is 6x squared, which is not what we want. We want negative 2x squared. So it must be that whatever comes next is going to combine with this to give us negative 2x squared. So our next term needs to be negative 4x. 2x times negative 4x gives us negative 8x squared, which does combine to make negative 2x squared. 3 times negative 4x is negative 12x. Oh wait, this one's actually not too bad. I thought it was going to have something crazy, but this actually works out really nice. We don't want negative 12x. We want negative 6x. So it must be that the next term has to give us negative 6x. 2x times 3 would give us positive 6x, and when we combine negative 12x with 6x, that gives us negative 6x. 3 times 3 is 9, and that works out automatically. So it looks like our quotient was this group right here, 2x squared minus 4x plus 3. Sweet, and I have no typos because all the answer choices are different. All right, so that's the end of our homework. Hope it helped. See you guys in class tomorrow or Friday or whenever this is. Bye.